So, today we are going to talk about radiation safety during interventional pain procedures. So, to introduce you to the concept of radiation, radiation is a form of energy. As you can see, it is transmitted in the form of waves or rays, and actually it can cause radiation sickness and DNA mutations that can lead to injuries to the human body. There are several different types of radiation, including alpha, beta, medical X-rays, gamma and neutron rays, and the alpha rays are the weakest ones. They cannot even penetrate the paper, and if you can imagine a paper and a regular source of light, then the alpha rays are the regular source of light which will not penetrate the paper and go beyond that. Compared to that, the neutron rays can even transmit through the concrete. The X-ray, medical X-rays are somewhere in between. They can transmit through the wood, but they will not be able to penetrate concrete or steel or any other metal. Radiation sources are many in the atmosphere and also generated by human beings. So, as can be seen, radon and thoron are the natural sources of radiation, and majority of the radiation, half and half of course, is divided between the medically generated radiation and naturally occurring radiation. The radiation was accidentally invented by Madame Curie in 1898, and she called it polonium because she was from Poland, and that is why the material was called polonium. And later on, Röntgen actually invented the X-rays, which are the form of radiation as we saw before. She had left her ring in a drawer with some radioactive material, and the ring actually lay on top of a film, and accidentally the film was exposed by the radiation, and it created the impression of the ring on that paper. So, that is how she discovered the radiation and how it can imprint the metal on a given surface, and then it was the X-rays were invented by William Röntgen. So, there are some important terminologies to remember here, and the main relevant terminology is mainly three different terms: the time, the distance and the exposure. The time is the duration of the emission of the X-rays. So, when the X-rays are emitted from the tube, the duration of how much time is the tube active is considered to be the time for the radiation. Then there is distance. So, the X-ray particles die down fairly quickly. So, the air actually does act like a barrier. So, if the X-rays are traveling through the air, every time it goes to a certain distance, it dies down. So, if the distance is twice as much, the exposure becomes 1/4 of the original source, and the exposure means it is measured by how strong the radiation is, and it is measured in milliamps and kilovolts peak or kVp. So, MA and kVp are the two terms that are used to describe the X-rays, the medical X-rays. So, if you look at the range of the fluoroscopy machine that we use, they are digitally enhanced images. So, they use a very weak form of radiation, and the total amount of power that it can emit is between 2 to 6 milliamps and between 75 to 125 kilowatt peak. Compared to that, the diagnostic X-rays that we get for example chest X-ray or kidney and bladder X-rays, they are much stronger, and their range is between 50 to 1200 milliamps and 50 to 150 kVp. So, if you take a typical 1 minute of fluoroscopy, that is converted into 100 milligray units, and we will talk about the gray units which are the SI or standard international units to describe the radiation. Your cell phone, for example, and when you are taking the picture of a dark place in with a cell phone, the cell phone's circuitry will digitally enhance that picture, so it does not look as dark. By the same token, if you have a very bright and very dark source side by side, the circuitry will try to neutralize that and make the brighter either more bright or darker more dark, and that way it will neutralize the complete tone of the picture. And the X-rays in the fluoroscopy unit work in the same way. They create a picture that is digitally enhanced by the circuitry so that the picture becomes more clear. And there are also some other terms that we need to remember. One is the exposure, of course, ionization product produced in the air by the X-ray or gamma radiation is measured in R, which is the Röntgen unit, or the Coulomb, and which is the SI unit. Radiation absorbed dose is the second term that is very important, and that means the actual energy that is absorbed by a given sample of the biological tissue, and that depends on the matter on where the tissue is being hit by the X-rays, and that is measured in RAD, radiation absorbed dose, and the rads are 100 rads equal to 1 Gray unit. Then the other term is radiation equivalent man, and that means the biological effect of the radiation. So, if you combine all these three terms together, we are talking about the source of radiation where the exposure is coming out measured in coulombs, then the biological tissue that is exposed to that and how much energy is being absorbed, and then the effect of that energy, the biological effect produced in the human being, is measured in REM. So, by all practical means, 1 rad equals 1 Röntgen equals 1 REM. So, they are equivalent in because if you expose a human body with an X-ray, the amount of X-ray that comes out is the same amount that is going to hit the human body, and the biological effects are also going to be dependent on the same amount. They will not be reduced by any other method. And another term is called millisievert, and that is mainly the term used to measure the amount of radiation that is exposing a physician, for example, and we measure it with the use of a badge that we wear around our thyroid collar, and some people also wear it as a ring or even on their eyeglasses to measure how much radiation their lenses are getting in the eye. Now that we are talking about radiation and the fluoroscopy, we have to look at why we use the fluoroscopy and what are the real advantages of fluoroscopy. We use that for precise location. We can use it to locate the osseous elements of the human body and thereby locate the anatomical place of where we are providing the treatment. So, precise placement of a needle can be performed under the guidance of fluoroscopy, and we can also use it as a live visualization of injectate. If we inject a radio opaque substance, then we can see that live being injected into the human body, and that will tell you if the medication or the injectate is going into a blood vessel or artery or a vein, or is it going in the proper place around a nerve root, for example, and whether we are having a proper injection performed in the way we want it. Also, the ability to save the fluoroscopic image or even the live cine video of injectate is possible with fluoroscopy units. And the main advantage is the portability and flexibility. Fluoroscopy unit that we use is called the C-arm, which has a C-shaped receiver and transmitter elements that can be rotated, that can be moved in 3 different axes of plane, and we can obtain a proper fluoroscopic image of the area being targeted. Also, because of the digital enhancement, we have low radiation exposure to the human body. So, that is a big advantage. We can recognize vascular injections, and we can see live contrast spread of the injectate. There are principles of proper use of radiological equipment, and for that you have to know your equipment. Just like when you are driving a car, you have to know the car first on what the buttons are meant for and how to drive the car and how to get to a certain point in a safe manner. Similarly, for X-ray equipment, we have to use all the knowledge that we have of the radiological equipment to have proper use and safety, as well as to get optimal output. So, There are several safety features that are built into the machines themselves. There are radiation attenuation factors, like they emit low dose and they have a higher digital enhancement. There are also a low dose parameter where a total amount of X-ray coming out of the tube is low, and then we can also limit the amount of X-ray coming out by collimating, which means the amount of field from through which the X-rays come out can be limited, and we will go through the examples of that later on. The three most important factors that are important in reducing the X-ray amount absorbed by the human body are the time. Of course, the burst mode is better than continuous mode. Instead of continuous X-ray, we are only going to use intermittent X-ray, which will cut down the dosage by significant amount. Then the distance, that is more important for the physician, because the patient is already under the X-ray, but the physician can stay away from the X-ray, and thereby putting more barrier of air between the X-ray radiating tube and himself, and thereby reducing the amount of dose that his body is going to absorb. And then we use the extra barriers, and that means the leaded apron that we use, the thyroid collar that we use, leaded eyeglasses that we use, or even leaded hand gloves that we use are all attenuating factors. They most of the time they would not allow any X-ray to pass through, but for example, in the gloves, the amount of lead is much lower, because the gloves have to be flexible for you to be able to hold the needle. So they can attenuate the amount of X-ray coming out, absorbed by the body, but they will not be able to completely stop it. And it is very important to measure the amount of radiation that your body has absorbed over the time, and the monitoring is done by dosimeters. They are the devices that measure the exposure from the X-rays, and they can be worn in several different areas. So the dangers of X-rays were realized long time back, and one of the first death that resulted from ionizing radiation was in 1904, and that was Thomas Edison's assistant by the name of Clarence Daly, who died because of radiation, and he actually had cancer, and ironically his cancer was also treated by radiation, but that was therapeutic radiation that was targeted to cancer cells to kill the cells. But if that radiation is applied to normal cells, even the normal cells can die. There is always some false sense of security while using the X-ray in most of the physicians who use them. Just because you don't see the X-rays does not mean they are not there. So the exposure of the radiation to the physician, the staff, and the patient is ignored by several physicians, and just because you don't see the X-rays does not mean they don't exist. And on the other hand, just because you are focusing on the target and you are seeing the target, then you lose the focus on the X-ray amount, and you are so engrossed in reaching your target that you forget that your foot is on the pedal and the X-rays are continuously being delivered to the patient and even your hands.